Hey guys, we're going to be continuing here with our chapter on systems of equations. So today we're going to be looking at solving systems by using what's called substitution. So solving by substitution is when you solve one equation for a variable and then substitute the expression for the variable in the other equation. In other words, we're going to isolate one variable and then use that to substitute into other. And we'll look at some examples that'll make more sense in just a moment. But first, photobombs. I love a good photobomb, especially when it involves farm animals. Yeah, that's high quality right there. Plus that horse is stuck. All right, so using substitution says, what is the solution of the system? Use substitution. There's one thing that I want you to always try to find. Where is there an isolated variable that already exists? If there's an isolated variable, then that's what you're going to be using to substitute. Here's what I mean. Notice that this y here is already isolated. It is by itself. So what this says, it doesn't say the answer to y is 3x. That's a common misconception I hear students say often. It doesn't say that. It says that the value of y is the same thing as whatever 3 times x is. Or 3 times x is the same thing as the value of y. These two things are the same. The value of this is the same as the value of that. So what that means is if I come down here and I look at this other equation, I have x plus y equals negative 32. What that means is that this plus y here is the same thing as a 3x because of this equation. This equation, this top one, tells me that this is 3x. So this is why it's called substitution. If I know that y is 3x, then I could substitute 3x in for the y because they are the same value. It doesn't change this equation at all. Again, because they're the same value. So I'm going to, let's do that. So I'll have x plus 3x equals negative 32. And then I go through and I solve this equation. So I'll divide by 4. And I get x equals negative 8. Now that is not the solution to this. All right, to find the solution, remember when we are looking at solving systems by graphing, we are looking for that intersection of the graph. And the intersection of the graph tells me the ordered pair where both equations are the same. All right, what is the one ordered pair where it works in both equations? So that's what we're looking for. If I only have the x value, I only have half of it. So in order to find the other part, I have to take this value and substitute it back into one of these. It doesn't matter which one. That one's easier though, right? Because that's a function. I have an output right there. So I'll do y equals 3 times negative 8, which is negative 24. There's my other value, so that my ordered pair is negative 8, comma, negative 24. Now, I've talked about this all year long. One of the things that I really like about algebra is that you can always know if your answer is correct. It works in system of equations. You just substitute this back in. So let's try this first one. It says y equals 3x. Well, 3 times negative 8 is negative 24. So I know that that works. The thing with the system is you have to check both of them. It might work for just one, and students sometimes will move on. They say, oh, well, it works in that first equation. I know that it must be correct. Don't make that mistake. Make sure that you are checking both equations. So I'm going to substitute in right here, and you can just do this with mental math. That's fine. If it's more complicated, you may want to write it out. But for now, mental math is fine. I got negative 8 plus negative 24. Negative plus negative is going to be a negative, and then 8 plus 24 is 32, so that one works out as well. Here's one for you to try. You have a 3, 2, 1. All right, I got negative 8, negative 9. If you did not get that, you may want to pause and check through my work here to find that. Hopefully you got it. All right, solving for a variable and then using substitution says, what is the solution of the system? Use substitution. You'll notice here that none of the variables are isolated, right? I have a y, it's got a 3 plus 4x, x with a plus 3y and a 4. Down here I have negative 2x plus y. So none of these things are already by itself. So I need to isolate one of them. What I always look for when I do this is, are there any variables that do not have a coefficient? Which this one right here has no coefficient, so that's the one that I'm going to go for. In other words, I want to isolate this y. So the first thing that I would do would be add 2x to both sides. And I'm left with y equals 2x minus 3. All right, so I've replaced this equation with this, or I've just manipulated it a little bit so that it looks a little bit different. It's the same equation. Now I have an isolated variable that I could substitute in. So I'm going to take this value and substitute it into the other equation. Be careful, because sometimes I'll see students where they'll isolate the variable, and then they take this value and they try to substitute it back into that same starting equation that they used. And that's going to mess you up. So make sure that you're not doing that. Make sure that if you isolate on one equation, you substitute into the other equation. So here I'm going to take this value and I'm going to substitute it in for this y. So I'll do this so I have a little room. 3, and then instead of y, I'm going to write 2x minus 3, because this says that y is the same thing as 2x minus 3. And then write the rest of the equation, plus 4x equals 14. I'm going to distribute my 3. So 6x minus 9 plus 4x equals 14. Combine some like terms. 10x minus 9. Add 9. You get 10x equals 23. Divide by 10. X equals 2 and 3/10. So there's my x value. Now in order to find my y value, I substitute back in. Be careful, don't use this one. Even though it may look like it's easier to use, just in case you made a mistake, you want to always make sure that you go back and use one of these. So I'll use the second one here. I have negative 2 times 2.3 plus y equals negative 3. This is negative 4.6 plus y equals negative 3. Add 4.6. And I get y equals 1 and 6/10. So my ordered pair is 2 and 3/10 and 1 and 6/10. This is why substitution right here is a great example as to why this is so important. Notice that these are decimals. If you were trying to solve this on a graph, it would be difficult to determine that that's 3/10 and 6/10. You know, if this is my graph right here and just some random grid, this point's going to end up like somewhere in the middle of a grid. And it's going to be difficult to decipher what that value is. But this is an exact answer. If you're using a graph for this, it's an approximation. But this is going to give you an exact answer. It's a better method than graphing. Graphing is good for like a quick estimate or if you need a visual representation. But for this one, you know, substitution is absolutely the way to go. So you could check that. For sake of time, I'm not. All right, there's one for you to try. The answer will be up in 3, 2, 1. All right, here's what I got: 7 1/3, and then negative 4 7/9. I get some ugly fractions in here, so be careful with this one. If you did not get that, go back and check. Be careful approximating. Stay with a fraction. Don't convert these to decimals because they will repeat. So if you converted this to a decimal, then you would have negative 4.7 repeating. And then when you try to substitute that back in, it changes your answers around a little bit. So leave them as a fraction. Also notice that I isolated the x on this one. You don't always have to isolate the y. Remember, this had no coefficient. So that's the one that was an easier choice to make. All right, so using system says a snack bar sells 2 sizes of snack packs. A large snack pack is $5 and a small is $3. In one day, the snack bar sold 60 snack packs for a total of $220. How many small snack packs did the snack bar sell? All right, so I know that the total of small plus large is 60 snack packs. That's the total that they sold all together. And then I also know that a small is $3, so 3 times S plus 5 times a large was $220. Now let me explain this. This is just the number sold. That's given right here, the number sold. Small plus large is 60. This is the price. Okay, so whatever the number of small is, I multiply that by 3 because it's $3 a pack. Whatever the price, whatever the number of large is, I multiply that by 5 because that's the price, so it's 5 times L. Add those two values together, and that's the total dollar amount. So here I have one equation, two equations. That makes it a system. Okay, so we want to solve for S, which means I want S in the equation. So over here I'm going to isolate the L. So I'm going to subtract S. So the number of large, this makes sense. The number of large is going to be 60 minus the number of small. So I'm going to take this value and substitute it in over here. So I have 3S plus 5, and then I'll substitute in 60 minus S equals 220. Then we go through and we solve this equation. So I have 3S plus 300 minus 5S equals 220. Combine some like terms, I get negative 2S plus 300 equals 220. Subtract 300, I'm going to run out of room here. Negative 2S equals negative 80. And then I'll divide by negative 2. I know that's really tiny, but you guys have good eyes. You're young. S equals 40. So the number of small packs is 40. Now, for the sake of time, I'm not going to go back in. Just notice it says how many small packs. That's all you need to answer this. You should go back and find the large packs just to make sure that it works. But I only have a couple minutes left here on my video, so I'm going to move on. But that answer is correct. It is 40. So, yeah, 40 small packs. There's your answer. Let's keep going here. All right, systems with infinitely many solutions or no solutions. This is what happens if I substitute this one in right here. I'd have 3.5, and then I'm going to substitute negative 2y plus 4 plus 7y equals 14. Notice what happens on this is when I distribute that, I get negative 7y plus 14 plus 7y equals 14. Well, negative 7y and 7y are gone, right? When I combine like terms, I get 14 equals 14. When that happens, that means that these are the same lines. So that is infinite solutions. That's what you'd say, infinite, solutions. So that is your answer on this one, okay? Over here, if I substitute this in, I'd have 3x minus 11. So I'm substituting this in for that y. Minus 3x equals negative 13. These eliminate one another, and I'm left with negative 11 equals negative 13, which is not true. So when that happens, that means there is no solution, which also means that these are parallel lines. Okay, so just be aware that those situations may happen. I don't want those to catch you off guard. And I think, yep, that's it. So I'll see you in class. Make sure you're taking good notes on this.